So you establish in a confidence interval that only about 10%, plus or minus a little bit, of students have had concussions in the past. And the coach says, wow, he says, I thought it was much higher than that. He goes on to say that he administered his own survey using a randomized systematic method after football practice one day, and his percentage was closer to 25%. Of course, you suspect convenience bias in this survey. It was after practice at football, and I suspect football players get concussions at a higher rate than just the average student. Okay, so you explain that to the coach, and the coach says, okay, so I see your point a little bit. So the coach revamps, and he says, well, you know what, I'm going to just prove you wrong about this 10% thing, and he decides to go out and do a completely randomized, I should say, a simple random sample, so an SRS around the school, and so an SRS, and he does, and you check with him, you coordinate with him, he definitely gets a nice simple random sample, and he collects a sample of 100 students, and you have well over 1,000 in your school, and he finds 14 of them, and he goes, see, told you. So my p-hat came out to 0.14, and that is evidence that it is much higher than 10%. So you guys decide to, in an effort to kind of look at this from what's the chance of that happening? Because he does recognize that that was 100 that he randomly chose, and you get natural variability even in random sampling, and that maybe you could get 14% when the truth is that this school only has about 10%. So you take a look at this idea of simulation, and this is just a typical graph that you might get to look at a simulation-based inference. And here, I'm going to just reset the simulation, add samples. Okay, so here's another sample that just came out of the hypothesized 10%. 100 samples were added just to kind of keep it easy in terms of percentages. And I just wanted you to recognize that, hey, the graph is somewhat centered around 10, maybe a little higher than that, but, in fact, over here we got 10.5 is the mean of this. The most recent result, they had 8 out of 100 that had concussions, but that just shows natural variability. So this particular dot right there represents 6 people out of 100 in that simulation. And so what they did is they set up some kind of a randomized feature that says, hey, the base should be about 10%. Now randomly select 100 people from this population, and what do you report back? And they did this 100 times. And what you can see is that, yeah, there were a bunch that came up with 14s. In fact, counting greater than or equal to 14 shows that there are 19 dots, or 19% of the time it was at 14 or higher. So that just tells the coach that, okay, even when the truth is 10%, that 19% of the time you will get samples as extreme as 14 or even higher when you're doing random sampling amongst this population that really is 10%. So it just kind of indicates that, okay, you went and got your sample, but it's nothing unusual. It doesn't disprove the 10%. So the coach chills out, and you guys live to see another day.